Hi, welcome back for another 5 Caillou challenge. This is called ROT13. How can you tell an extrovert from an introvert at NSA? Oh, sorry, this is some gibberish. I found this joke on Usenet, but the punchline is scrambled. Maybe you can decipher it. According to Wikipedia, ROT13 is frequently used to obfuscate jokes on Usenet. For this task, you're only supposed to substitute characters, not spaces, punctuation, numbers, etc. So consider these test cases. You've got this gibberish goes to ROT13 example, and then this is my first ROT13 exercise goes to this gibberish. And to sort of understand how these translations happen, you should follow the Wikipedia link. And this picture right here makes it very clear. You can see any A character goes to an N, and conversely, if you have an N, it goes to an A. So it's like all the letters of the alphabet. Since there's an even number, there's 26. You've got sort of 13 of these pairings, and you just use the other version. So if you have an N, use an A. If you get a D, put a Q. If you have a T, put a G. Pretty easy encoding to use. It's a special case of the Caesar Cipher. If you're interested in that, do all of the reading you would like, but not necessary for this video. Notice the ROT13 is sort of short for rotate by 13 places. So that's sort of the offset that you use to get to the letter that you want. If you're early in the alphabet, then you're going to add 13. And if you're later in the alphabet, you're going to subtract 13 to get back. That's sort of your hint for this exercise. I suppose I didn't need to tell you that, but hopefully it serves you well. Go ahead and pause the video and take your attempt at this, and come on back when you're ready. Okay, I'll get right into it. I'm just going to make my own solution. Nothing fancy. We're just going to use the basic bread and butter here. I'll make a result. You could also use the string builder class, since we're going to iterate over all characters of this string and process them one at a time. I'll use just a regular string here, but remember that string builder is kind of handy when you're modifying a string a lot. We know that strings are immutable. They sort of work like they are mutable, but underneath the hood, there's actually some performance cost there. It has to allocate new memory, if I recall correctly. So that's why people opt for the string builder sometimes. So then, sort of in the middle here, we just got to process our input, right? So we could say for each char ch in input, right? And it told us to ignore basically characters that aren't letters. So I'm going to have two cases, right? We're going to have if, remember the char class has an isLetter function to check if we're dealing with a letter. So then you can imagine we'll use our encoding within this block, and then else it's some other character, and we'll just say result plus equals ch, the character. So in other words, we're just passing the character through when encoding doesn't apply. That's sort of what I'm trying to achieve here. Now we've got two cases within our two cases. So now I'm within the if block. I told you I had two cases first because it's the if and the else. But then under the idea that we have a letter, there's two other cases. We could have an uppercase letter or a lowercase letter. And you don't need the ASCII table here, but if you want to see, you can note that the letters are represented. So capital A starts at 65 and it increments all the way to Z, which is 90. And then lowercase a comes in at 97 and goes to 122. But the idea is that we sort of cut it in half. If our letter is N or later, we'll subtract 13. And if our letter is A through M, we're going to add 13 to get the encoded character. So with that said, we could say, okay, so we have a letter. I'll say if char is upper. This means we have an uppercase letter. So then we could say if char is greater than or equal to the character capital N, because remember we're dealing with capitals, then we'll say result plus equals char minus 13. Else it comes before N, and we'll say result plus equals char plus 13. And That looks good. I will cast it back to a character though, because remember, chars are kind of like an integral type, right? They have these values associated in the ASCII table. So what I want to do is to actually get the symbol of these. So what I'm going to do is I'm going to cast it to a char, this whole quantity here. And I'll do the same thing here. I want it to be a char. Maybe the second case I'll do without this conversion so you can see how it puts numbers in. And so the other case within here, right, is that we're dealing with lowercase. If it's a letter and it's not uppercase, that means it's lowercase, right? So we do the same kind of thing. If CH is greater than or equal to, but now we're dealing with lowercase letters, we'll say result plus equals char minus 13. Remember, I'm going to do it the wrong way here so you can see result plus equals char plus 13. I'm not casting this to a character representation. I'm just using the integral value here. When I subtract an integer from a character, it interprets that result as an integer value. Sort of like if you take a string and you concatenate an integer, it's sort of smart enough, or it by default it says, okay, I'm going to treat this whole thing as a string. I think you meant for me to concatenate the representation of that integer into the string. So same kind of concept going on here. And then, yeah, we covered the uppercase, we covered the lowercase. Let me see how this goes. Let's see what I did wrong here. Okay, good. So we got an error, but we expected an error because I just wanted to show you how they come out as integral values when if you don't cast them back to a char. So what was this? The example E, what should E have gone to? E should have gone to an R. E. So it said 101. It's 101. You can see the 101 is the E value, right? Plus 13 would get you to 114, which is the R value. So yeah, let's cast these two characters. We're building a string, right? That's why we want it to be a character and not just some integral value, because our return type is a string that we're populating with all these various characters. So let's make sure we're still dealing with characters here, and then you see we hit all the green. And bam, just like that, you're done. I'm not going to try to whip up anything cutesy using LINQ here. I think this is fine and expressive enough. Sorry, I should have done this again. I keep doing that. Okay. Wow, did it seriously just blow my answer away? Let me see if I can undo. I've never had that happen before. I was just trying to blow up the screen too late. Well, here, past solutions. Let's just take it back. Copy that. Paste it in. We'll hit the attempt again. Yeah, sorry about that. The technical difficulties there. That was a little bizarre. But I'll expand this so you can see it. Yeah, we just set up a string. Remember, you could use string builder here. That might be a better option since we're constantly adding characters to it. And then two cases, we're checking if we have a letter or not. If not a letter, just pass the input through. Otherwise, we'll distinguish between uppercase and lowercase. And then we'll say if the character's later in the alphabet than n or equal to that, we're going to subtract 13, right, to get to that lower value. And otherwise, if we're toward the beginning of the alphabet, we're going to add 13 to get the pairing. And it's just the same concept except with lowercase letters down here. So I'm going to go ahead and fire mine off. Get those honor points. And yeah, go ahead and check these out. Okay. Join input selection. Okay. So maybe they set up all the pairings between this S1 and S2. Yeah, that's one way you could do it. Regular expressions there. So yeah, there's some stuff for you to chew on here if you want to put some more tools in the tool belt, so to speak. Otherwise, you know where to find me if you have questions, and we'll keep rolling. So as usual, thanks for watching. I appreciate the likes and subs. I'll see you in another one.